been with the OSGi Alliance for a very long time, but of course he's also some other jobs beforehand. So since 1990, he already is an independent, well, actually engineer and consultant and research and developer, all of it together. He's been with the OSGi Alliance for a very, very long time. Then he decided for the good to go for a sabbatical, to develop his own stuff, and then he's come back and helped us to set up what he wants to talk about today. So please welcome Peter.
Good. Thank you, Susan. I'm very happy that so many people are here. As Susan said, I basically did a sabbatical last year, and that has resulted in some insight. It has resulted in a lot of learning. And it has resulted in a plan that we want to execute in OSGi. It's called OSGi en route. And I'll try to explain what drove us to that plan. Then, when I was making my presentation, I had made lots of slides. And then I realized that this is a technical audience, so I shouldn't do too much marketing. Normally, people from a technical side want to see something. So I actually prepared a demo, which I think I started the preparation 2 hours ago. So it's going to be a little bit dangerous, but I think it works because we are going to use something that I had prepared extensively for something else. And then we'll take questions. There's also going to be a buff about this subject. When it is? Tomorrow night?
Tomorrow night.
So there we would like to get some feedback on it. My sabbatical. I got involved with the OSGi in 1998 when I was working for Ericsson. And before that, I've always been extremely hands-on. I've written a lot of code in my life, and I like code. I like making implementations, applications. After 14 years of writing specifications, because I was basically the primary editor of the specifications, I felt that I was floating. You know, you talk about a lot of things and people listen to what you're saying, but I hadn't really done it myself anymore. Yes, of course, I built lots of OSGi things, but they were prototypes. And when you build a real application, it's completely different than you need to when you're in the field, when you're in the trenches, and you make your hands dirty, you learn a lot. And in those 13 years that I had been involved in writing specs, there's been a lot of things that came into the market. The whole HTML, web stuff, the Java 2 EE came into existence without me really getting a chance to build real live applications with that. So I decided to take off for a year, and one of the things that I always, with primary goal learning, and the secondary goal to start, if possible, a business around an idea that I had for a long time, which basically is a repository. One of the things that has been driving me to do the OSGi work, but also before that, I've been very active in the 80s to get, yeah, I'm that old, to get objects in companies. That's why I was working at Ericsson as well. I want reusable software. I want to build systems out of components. I don't want to have to write lots of glue stuff. I want to be able to slap them together. They should be able to discover each other, adapt to each other, and that should build 80 or 90% of the system that you're supposed to build. I've been working on that in many different capacities from the 80s, and the OSGi has been the perfect vehicle because we made that really strong, well-defined framework that provides these substrate on which we can build. But one of the key parts of a reusable model is that you have a repository, because you can have the most perfect frameworks to build applications, but if there are no reusable components, then you're going to be out of luck. You need a marketplace to do that. So I decided to build JPM4J, which basically currently is a big repository. It's not commercial because the commercial part was harder, and I'm not really that interested in the commercial aspect. There's still a lot of stuff going on. I tell you a little bit about what it is. It currently got 500,000 jars in there, mostly from Maven, but also from other places. 50,000 programs. It has a very thorough index on it. You can do full text search. You can look for packages. You can look for all kinds of cool stuff. It does a lot on the dependency graph of the different components, so it visualizes it. The whole release schedule. the version history. You can compare versions to see what the binary differences are, what the API differences are. So there's a lot of cool stuff, and it's a lot of the knowledge that I learned working for the OSGi. Is anybody using the Maven bundle plugin? Yeah. Sonatype told me it's one of the most downloaded plugins outside the core Maven plugins. It's very popular. I'm the author of that plugin. I'm the B&D developer, so I can use a lot of the knowledge that I have from that. Anyway, this was a lot of fun, and I really feel up to shape. Especially, I'm very proud of myself that I think I almost have understood CSS after spending about 30% of my time on that. But I also learned CoffeeScript and JavaScript and HTML, and really trying to make something that actually works. Now, one of the things that I did, because it was my own project, it was my sabbatical, I didn't have to answer to anybody, and because I have been talking about OSGi so much, I did something that in a normal company, it's not an easy choice. I said, I'm not going to compromise. Everything has to be done the OSGi way. Now, what is the OSGi way? That means that you make things service-based. The big problem that OSGi is running into is that people look at it, and they look at the specification, and they say, wow, nice architecture, and well done. And then they start using it, and they run in all kinds of boundaries, because they're trying to apply basically classic Java patterns to it, which have intrinsic modularity problems. I'll talk about that a little bit later. So I started from scratch, and it meant a hell of a lot of work, and it meant 13, 14, 15 hours work days. Not being paid is kind of strange to work that hard. But I had a lot of fun, actually. And I really built a completely service-based system. The big problem that you run into is you have to build everything yourself. Because you go to the open source and you find something that looks applicable, but then it's not just doing that single thing that you wanted to do. You've tried to find a security framework, and it's doing security, but it is also doing config admin, and it has a web interface, and it has all kinds of other stuff. The problem is even though there's a hell of a lot of good stuff outside in that world, and with this work I discovered a hell of a lot of good stuff, most of it is not very cohesive. So that is basically, even in the open source, it would be nice if a lot of the projects out there would be more cohesive and would be easier to combine with each other and didn't try to do the kitchen sink and a little bit more. So why are we running into the problem? Because this is the biggest problem. We'll find that lots of things are coupled to each other. Everything seems to be connected to everything else. The weird thing was, when I was working in this object-oriented world in the 80s, there were the structured people ahead of us. That was the 70s, where people tried to tell you that you had to make structured code, you had to put things in functions and into modules. There were no classes at the time, and they were always talking about high cohesion and low coupling. The weird thing is, when the young kids at that time, that was me, we came in there and we said, oh no, objects are great, objects are fantastic, there's new technology and all this cool stuff. And actually, I think when you look at a lot of stuff, we forgot about that high cohesion and low coupling. And we created enormously coupled systems, especially in the 80s and the 90s later. There have been disasters. When you look at Java, it tried to address it, but it created another mess. If you see the number of factories in there and what we have to do with the dependency injection engine, is trying to address this problem that often a lot of things are too coupled. And mainly also, there's something a little bit more vaguer. The high cohesion is often missing. As I said, when you look at Hibernate, which I had to debug recently, then you'll find there's a whole dependency engine hidden in Hibernate. There's a whole transaction manager hidden in Hibernate, because they cannot rely on the external stuff, often because the specifications are so bad. There's a tendency to want to do everything instead of just trying to find a component that fits a specific part. I see you have a typo in here. The other part, what we found in the OSGi world, and which is very important, is that you're explicit about your dependencies. And that doesn't mean that you just create a whole lot of dependencies. If you go to Maven and you analyze, which I did for my subject that I worked on, you'll find that a lot of dependencies are not really necessary. They were necessary in certain cases, but they tend to pollute the whole space. So you get, due to the transitive, somebody once said that Maven downloaded the internet. And then the Maven guy said, no, it's not Maven downloading the internet. It's you downloading the internet because you don't handle your prompts correctly. You put too many dependencies in there. And because they're transitive, your dependencies have dependencies, which have dependencies, you get this explosion. And it's true, Maven doesn't download the internet. It's you that does it. But it's the same thing like, say, guns don't shoot people, people shoot people. It's too easy to create a problem. And anyway, the result is that when you really want to manage, like I know LinkedIn has almost 1,000 different open source projects in their build system. There's lots of other companies that really get a lot of open source. If you want to manage that, we'll have to be minimizing the requirements, and we need to make them computer readable so we can create management software that actually allows them to work. And I think OSGi is very far ahead in that with the requirement capability model that's in there. But the problem is it's relatively new, and there's very few people actually building that way the components that we need to make this basic, almost drag and drop kind of model. So meet OSGi en route. After I've been working on this for a year and developing this whole, I think I got 60 projects and there's about 100 services in the system to do my job. And as I said, I developed a hell of a lot of that stuff completely from scratch, learning a lot. I went to the OSGi and said, okay, I've done my sabbatical. The commercial aspect is hard, and I'm not sure I really want to spend a lot of time becoming a business person because I like technology. But one of the things I notice is that we really need something to make OSGi easier to use. I think what OSGi currently is, it's a perfect concrete slab. You can build fantastic buildings on it because it's a very solid foundation. I had to work with JPA, actually related to this, and I found the specification in many ways very much lacking. I actually made a demo with JPA using Hibernate and Eclipse link, and it took quite a bit of effort to find annotations that actually worked similar on Hibernate and Eclipse link. OSGi, I think, is very different. In general, when you make a bundle, it runs on Equinox, it runs on Concierge, it runs on Felix, it runs on processed framework. The specifications are good, the TCKs are, for the important parts at least, are pretty solid. But we need to do something about the adoption rate. And the way we need to do that, because if you look at OSGi, then the whole model is built not around multi-tenancy, it's not around a lot of stuff people trying to do with it, it's built about making an application, making the organization of an application better, making modules, as I said, components that actually build your whole application. So the en route project tries to create it's not a framework, we're not trying to push code downstream and build some project where we build a lot of stuff, but we're trying to create an ecosystem and we're trying to create guidelines and trying to go a bit further than we did so far to show how to use OSGi. Now this is the slide it's from an old presentation, because this is what OSGi really is. We got a lot of wonderful bricks. We got a lot of things that allows you to build all kinds of really cool stuff. In 1998, when I was working for Ericsson, there was one older guy, I guess he must be my age now, that I am now, that whenever I came from a meeting at the OSGi and I said, oh, look what cool things we made, and we can do this, this, and this, and he said, yeah, but how do we really use this all together to make, in that time, our e-books? Now there is this book, I'm not sure how many people read that, the marketing people usually know this book, it's called Crossing the Chasm. And there they explain this effect, is that as a technology person, you love details. You like to make, you can get really excited about a nice piece of code or a nice piece of technology. But if you get users that are not really deep into that technology, they actually need the whole solution. They need to be able to go there and get to work and not having to wonder, oh, this is a wonderful part, but where do I find all the other parts? So the whole solution is crucial in trying to deliver that. So in the OSGi en route project, what are we going to do? This is still not definite. I actually should have one of those Oracle slides where I say that everything I say cannot be held against me. I'll have to do that as well. This is not an official OSGi Alliance. We are working on trying to find what we're going to do here. But it's pretty ambitious so far. We want to make a demonstration chain. We basically want to make a whole end-to-end OSGi way of developing, where we try to use the best practices that we have learned over the past 10 years, 15 years, so that you can actually go to a GitHub repository, you check it out, and everything is in there. Your IDE, your Java compilers, your build in the release tools, the continuous build. That's what we want to build to show this is how, not that you have to use this, but you get an example of, okay, this is how I could build OSGi stuff in the way it was intended to be, with all the advanced features that are in there, and then you can pick and choose and model it in the way you want to do it. But at least there will be one place where you can see the whole thing. User documentation, tutorials. There's many missing pieces. When I worked last year, there were very nice specs, but there was stuff missing in between that needed to be bridged. I did a lot of this stuff. What I'm going to try to get specifications out of that, so we'll go through the specification process. That will take time. And I will try to work with open source groups. I'm a committer in Equinox. I'm a committer in Apache Felix, and probably in a few other places. I'll try to work with them to try to get projects to fill in those missing pieces. We're going to get the repository in there somewhere, so that you're actually going to have a repository where every jar that exists that is public is going to be in there, and where you can also associate your private jars. Trying to build a community around that, that's hard nowadays, though we have a lot of social tools, so that should be a lot easier now. Pluggability, again, with this whole demonstration chain, we're going to pick tools, because otherwise you cannot demonstrate it, but we're going to make it as pluggable as possible so that you can make your variations. And going to try to work with vendors, for example, for deployment, work with HeroQ or CloudFront, Pivotal, these different vendors trying to make also a deployment story for people that want to deploy in the cloud. Now, time flies. Last Monday, there was an OSGi users group here in Ludwigsburg. And I gave an OSGi en route blog tutorial. It's basically a baby step to see how we can do this. What I did is I prepared, and I think there's some victims in the audience. I prepared 10 steps. And they were completely written out. You can take this and you can go from the beginning to the end. And I think there was only one syntax error in the copy paste. The PDF was hard to copy, but this is a work in progress. This will continue. It is a GitHub project, osgi.enroute.blog. It might disappear or not, because that depends on how we really continue. But at least this is a starting point where we want to show this is at least architecturally how we're thinking about it. This was the group. Atmosphere was really good, though actually the air was a bit stale. We had not a lot of air conditioning there. So what I'm going to try to do is show you the application. This application, it's the most simplistic blog application you can think of. It doesn't do anything realistic, but at least it talks about all the create, read, update, delete methods. It uses Angular for the user interface, which is a very nice match with OSGi because it has very similar modularity issues. This is the application itself. That's the block diagram, the bundles, and the services, and the extenders in there. And what I'm going to try to do in the next 10 minutes is 12. I can see it here. In the next 10 minutes, I'm going to go and show you all the 10 phases of that application, which the students struggled with because I don't think we got further than 5 or 6. But I'm going to show you the nice thing about Git is it's very easy to change your workspace. So pray with me that I'm not going to make big mistakes and that things are not going to fall apart. I'll mirror the displays. Okay, this is, I guess, familiar to everybody. The workspace actually started. I'm currently in 0.1 setup. There's a few projects that are disabled because they're currently not in the workspace. The nice thing with eGit is it will automatically enable them when we get there. So let me start the initial phase. Anybody been using OSGi knows that he can now do bundles. Then you get the list of bundles. So the framework is running. We got an application running, and we have on localhost, we get a file not found. There's nothing there yet. On the beautiful X-Ray, X-Ray is an application on web console that shows you the inside of the OSGi framework. I'll make it look for en route so that we can see the stuff on the en route. We have currently this bundle. Can everybody see it? That bundle is actually running. That's our application bundle that's running. So we're going to go back to the framework. And then we're going to go to phase 2. In phase 2, we're going to add a hello world. Very simple. Where is it? Release. Switch to, yeah. What this does, it basically creates an index.html file, and that contains hello world. So we go to the website, and we get a hello world, yeah? So, simple, but actually it took, I think, an hour before we all got there. But there was some configuration in there. So let's go to the third one. Team, switch to Bootstrap. Is there anybody in the room that doesn't know what Bootstrap is? Everybody knows what Bootstrap is? Yeah, okay. Bootstrap is a CSS framework made by Twitter. So it is about styling. It's about that stuff, that magic language called CSS that sometimes seems like it lives in another dimension. So we added Bootstrap. What I did here, of course, I didn't just add a Actually, when we look now at the web console, we'll see we added the Bootstrap bundle that contains the CSS, the fonts, and the JavaScript for Bootstrap. Of course, you don't automatically then get a nice styling. You still have to do something on your hello world to get that styling. But it shows you the idea. Then the next step that we were going to go into is we're going to add Angular. When we're adding Angular, we're actually adding a JavaScript program to the thing. So we're going to do it's very small, it's very tiny, it's some JavaScript. And of course, we changed in the index.html because we're going to change the user interface and all that kind of stuff. The first part, we're just going to, well, let's see what happened. We go back to, you see we have an Angular bundle now. Create a little block GUI, just a test GUI to see how Angular works, to be able to type stuff in the search bar, to do it in the title, content. If we add it, we want to see a list. And what we also added is a test data method so we can fill so nothing fancy, just to get a feeling of Angular. Angular is a fantastic JavaScript framework. It's very powerful, but you need to get some experience. So that's what we did. Then in the next phase, we wanted to talk to the backend server because we haven't done any real OSGi stuff now. Not really true. We added Bootstrap and Angular through OSGi bundles. So we use the whole OSGi deployment engine, and that's huge and very powerful because there's so much people that have built support around that model. We can use that and the whole version management, the baselining, all that works now for Bootstrap and Angular as well. But we want to talk to the backend because as Java developers that scary JavaScript. Actually, it was kind of interesting yesterday how the Java developers really detest JavaScript. So we're creating a backend in Java. We added this Java class, sorry, this one. It's a simple test method to get the block data from our server. And I'm just going to set a breakpoint there so that to see if that works. So if I refresh now, then the user interface is the same. But if I press test data, I'm actually going to go to the server. So we're going to go to the server. We see we're there. And I'm just going to continue here. And we're going back here. And we see we got the test data from the server now. So where before we completely stayed in JavaScript, we now actually made a round trip and we got the information from the server. And we can add it as well. So that was cool. Let's go to the next step. That was 06, which is going to do... There's a lot of options in Git. The block GUI. The next part, what we're going to do is actually develop a real block GUI. Make the create, make the read, make the update, make the delete methods. So let's see what got out of that. So now we have this is a test GUI. We don't go to the backend for the data, so there's a little bit of test data in there. We can click on it, so that brings us to the block. We can edit that block. I can change the title. We don't really save it because this is all mocked. So this is just to see if the user interface is working. Key thing in Angular is we use the URL. So this is a browse, a back, forward, buttons work, and you can send URLs to other people and they actually get in the right place in the application. So this is not a toy anymore. This is really, it's very small, it's absolutely minimal, but it is actually showing how you build bigger applications. The weird thing is that that part is very hidden in the Angular documentation. They have a fantastic modular architecture, but it's not easy to find, at least when I did it last year. Maybe it's got better in the meantime, but I did it completely wrong in the beginning. Anyway, I also added the function to call an exception because you want to test your error handling. So I can get a 500 error to see if I get a message. So we started to have something. So the next phase is, how do we, what do we do? Go away. We switch to the facade. So now in the Java code, we actually add all the REST methods. Post blog post is for the post. We add with the ID in there, so the update, the delete, the get. Let's go to the user interface. So now we should be able to browse. But now we have no post, because now we have a real thing. We don't have a mock user interface anymore. We need some test data. So the test data is now a remote call, but it updates the server list of blocks because we're going to get the blocks from the server. So when we create test data, we can see the list, we can edit it, we can cancel it, we can delete it. Okay, we can search it. That didn't really work very well. Did I delete that one? Alice, yeah. So the search work, all these different functions work now, which is pretty cool. And we do this on the back end. We now really get, but we have an in-memory provider there that basically we use a hash table to store those blog posts. So every time when I restart the system, all my blog posts are gone. That's not good, is it? So it would be nice if we at least, the other problem that we're having is we put the implementation of this hash table, we put that in the facade where we should do authorization and authentication, all this REST handling stuff. We actually put implementation stuff. So in the next phase, what we're doing is we're splitting. Let me show you that here. We currently have these three bundles. So what I'm going to do here is I'm going to go team, switch to memory provider. This creates a new project which is creating an API for the block manager. So now we're going to make a service and it creates a memory provider, the hash table implementation. We're going to put it in a separate bundle and we're going to talk with these guys over the service. So let's see how that happened. You see there is a service registered now. Everybody sees that? There's a block manager service now, and we have a memory provider, and we have a block API. So I can go to the user interface, and that's not going to change a lot. Well, it would be nice with test data, but that looks the same as before. We didn't change that. The only thing was we did the right thing. We made it more cohesive. Yeah? We made the block manager only know about block managers and storing them. And we made the facade, the block facade, the one that talks the REST calls, we made it smaller and being able to focus on its primary responsibility. So in the next phase, team switch to API tested. Then what you should do if you write an API, you should also test it, or in an implementation. So we created an en route block test program, and I can run that now. For example, the block test. I want to test this method. And the problem, if you realize that, is you need to run OSGi to do this. Because this is not a unit test, this is really an OSGi test. You need a bundle context, you need the whole OSGi environment. So I'm doing this now here, and this actually ran a JUnit test on that class here. So this is completely integrated with JUnit. You can do all your JUnit testing that you want to do. Just like normally, but actually you run it inside an OSGi framework. And the way that is set up is that you can use that test also now to test other providers, because it was not bound to a specific provider. Anyway, the last phase is, and I'm going to kill the process here because we're going to do it a little bit different. The exception was from when I clicked on the exception. This was not this was the Yuk exception, so this was not an error in the program. So the last part, and I'm almost there, is in 10, I tried a heroic effort to get JPA completely portable. I wanted to do runtime switching of JPA and between Hibernate and Eclipse Link and MySQL and H2 and do all the combinations. That's impressive, isn't it? Yeah, I see somebody that has been trying to do that. I won't show that here because I already get angry looks from Susan. Let's go to the last one, that is the APA. So now we have one, and one thing we're doing here, because we want to deliver our application outside this world, we're not using the normal development runtime. That's why I stopped the one we had been trying out where you saw the new interface, the user interfaces. I killed that, and we created a run file to run the block application as a separate application. That one runs the same, but this one is set up to use JPA. So we're running it. As you can see, you get a lot more logging suddenly. It becomes a lot more enterprisey. If we go to the user interface now, I can't find that post because I need test data, and actually like this. So this stuff is actually now stored in the user interface. It's using JPA to store the information. We're running this now from enblock.bnd run. So let's go to the command line for a second. I'm going quite fast now, I know, but you have to forgive me. I'm here, and you can see can everybody, let me enlarge that. We got the enblock.bnd run file here, yeah? What I can do is bnd package yeah. What this generated was a enblock. It was already there, but it generated a new copy of enblock.jar file. Now this jar is not a normal jar file. It contains a launcher, it contains the setup properties. It's identical to all the information that is in that enblock.bnd run file. So the run file specifies my environment, all my dependencies, and this creates a single jar that contains everything in the world that it needs. It's complete. So I can run it now as java -jar enblock.jar. Yeah, so the application that we just developed in the last 15 minutes is now actually running as a jar file. And of course you would like to, and that's a little bit of advertising for myself then, you would also like to be able to run this from the command line. I would like to be able to type enblock, and that should work as well. Wouldn't that be great? I could write shell script, but let me do it differently. Let me show clear terminal. So I just installed it, and now I'm running it from the command line. And the beauty with the JPM server is you can actually automatically store it on the server if you have an account, and then anybody in the room could have installed it. Okay, I think I made it in time or not.
I know we are running out of time. Is there one question? If not, just keep up with